This is geometry. This is our final day on CPCTC. We also consider corresponding parts of congruent triangles to be congruent. We say if two triangles are congruent, then corresponding parts are congruent. So if you know triangles are congruent, then you know that the other parts, corresponding parts that we haven't talked about, must be congruent also. So in this first example, it's just considered a warm-up. We're going to talk about why the two triangles here are congruent. We're given a piece of given information. So that's already labeled in our figure. We have AC congruent to EC. It also tells us that ED is perpendicular to BD. So if it's perpendicular, then we put this box in the corner. We also are going to have another box of AB being perpendicular to BD. So there's our other box. The third bit of information they're going to talk to us about is that C is the midpoint of BD. So there's no marks that happen when C is the midpoint, just using those words. But if a point is a midpoint, then it divides that segment into two congruent parts. That's why we're going to put tick marks onto those segments. Because if C is the midpoint, then it's dividing BD into two congruent parts or into two congruent segments. Now we look at the information. In the chat, share with me why you think these two triangles are congruent. We have 5 ways to do that. So what we're looking at here is that we have a right angle. So right angles could either be congruent, so we could consider that an A. And then we have these two sides, but that's not one of the methods that we use to prove triangles congruent. We can only use side, 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 which we don't have. We don't know those third sides. Side, angle, side, but we don't have the angle in between the S's, so it's not that one. Angle, side, angle, but we don't have two sets of angles for the same triangle, so we don't have that. Angle, angle, side, no, we don't have two sets of angles. And then RHL. Oh, you're right. We have right triangle and we have the hypotenuse and a leg. If the triangles are congruent by RHL, then we've got to show that they are a right triangle, that the hypotenuses are congruent, and that the other legs are congruent. So in the very beginning, we're told that we have given information. We've already labeled that on our picture. This perpendicular was the box that we put in the figure. So the box was angle B, comma, angle D are right angles. If perpendicular, then right angles. If perpendicular has to come earlier, then is happening right now. Then we are talking about right angles. Now, why do we even want to talk about right angles? This R for RHL has to be right triangles. But the only way for us to get to say that we have a right triangle is to identify we have right angles. So now we're going to talk about triangle ABC, comma, triangle EDC are right triangles. If right angles, then right triangles. So if our triangles have a right angle, then the triangles are right triangles. We showed that we have a right angle. So now I know that I have a right triangle. If comes earlier, then comes right now. We have the other piece of given information. So what happens if we have a midpoint? Can you send me a chat letting me know what two segments have to be congruent? What haven't we mentioned in this proof so far? What haven't we specifically said? What's going to go in your statement number 5? So we're going to prove, or we just showed that two segments are congruent because of our midpoint. If midpoint, then two congruent segments. Now, since we look at this and we have R because we have right triangle, we have H up here because of the given information. And down here, we came into knowledge that these two segments, so it's not in perfect order, but it's R, H, and L. We showed that we had right angles congruent. We showed that the hypotenuses were congruent. And we showed that the legs were congruent. So that's considered RHL congruence. We're going to look at our next example. And again, the way we do all of these proofs is to look at your given, see if you can find it, and can you work to this conclusion? Do you know that C is the midpoint? Well, when we come over here, C is the midpoint of AE. That's what we want to prove. Let's see, I don't know that yet because I don't know I have segments congruent. What makes a midpoint? Segments have to be congruent. You've got to divide AE into two congruent parts. I don't have that. What can get me there? Well, I know these are both the hypotenuses of these triangles. So if the triangles are congruent, then I know these corresponding parts are congruent. Well, why would the triangles be congruent? Triangles are going to be congruent because I have a pair of right angles. I have a pair of sides. It shows here that they're congruent. Now, you might think that you would use RHL here, but remember, it's the H that we're trying to show is congruent. We don't know that, so we can't use that to prove something else. We don't even know that here. So we can't use RHL. We would have to use the vertical angle. So we're going to use angle side angle to prove the triangle is congruent. And once the triangles are congruent, then we're going to know that their corresponding parts, like the hypotenuses, are congruent. So if that's true, then AE has two congruent parts, so it has a midpoint. That's your plan. You've got to convince yourself this is possible before you even start. So there's your given. Then we come down. Is there any part of this given that we can talk more about that isn't really specific? This given said that BC was congruent to CD. It told us a pair of sides were congruent. But it also talked about this perpendicular part. Perpendicular gives us a box, but what does perpendicular mean? it's going to tell us that angle B, comma, angle D are right angles. If comes earlier, what was said earlier that made us think this? The perpendicular. So if perpendicular, if two segments are perpendicular, then we have right angles. If two segments are perpendicular, then right angles are formed. You can have it shorter just like that. We come down and we talk about B. Why would they be congruent? Nothing says they're congruent. They talk about segments being perpendicular. That made right angles. Oh, right angles are 90 degrees. So 90 degrees are the same. So they would be congruent. So if right angles, anytime you have right angles, then you know the angles are congruent. Then we have congruent angles. What's another thing? So here we've got an S, here we've got an A. I'm looking for another piece of information. The other piece we haven't talked about are these vertical angles. So I know that angle BCA is congruent to angle DCE. If vertical angles, then congruent angles. That also makes angles congruent. If you have right angles, that makes them congruent. If you have vertical angles, that makes them congruent. So the triangles are going to be congruent, not because of the order we wrote this in. Unfortunately, we didn't write this in the same order as the picture. In the picture, it was an angle followed by a side, followed by an angle. Angle, side, angle. Congruence. So watch what we're going to do here. Remember, we're trying to prove that we have a midpoint. If we have a midpoint, then I must have segments are congruent. So for me to show I have a midpoint, I need to know about my segments. Why would those segments be congruent? Why is AC congruent to EC? Well, that's because the two triangles are congruent. Notice the first two letters are congruent to the first two letters. Those are called corresponding parts. If triangles congruent, then corresponding parts congruent. So now you know why those segments have to be congruent. And if the big segment is broken into two congruent parts, then we have a midpoint. If a segment is divided into two congruent parts, then it has a midpoint, not plural, but it has a midpoint. The big segment is divided into two congruent parts, then that spot in the middle is a midpoint. You could use some more words in there if you like. Any questions about that? All right, last one. Here we have parallel lines. So we know that this line is parallel to that line. We also have a segment congruent to another segment. So we're going to talk about how AB is parallel to DC. We're also going to talk about AB being congruent to DC. That's a pair of sides that are congruent. That's our given information. When we see parallel lines, we're supposed to recognize alternate interior angles. So angle 4 and angle 2 are congruent. If parallel lines, then alternate interior angles are congruent. We also have the reflexive side, that DB is congruent to BD. That's the reflexive side. So even though, I guess we listed it in the exact order that we're proving it in. We know that the two triangles, triangle ABD is congruent to triangle CDB. We know they're congruent by a side angle side. So we know that their final angle, ones we haven't talked about yet, they would have to be congruent. If triangle is congruent, then corresponding parts congruent. And notice if those angles, which are also a type of zigzag angles, that's going to make another pair of lines. And that's what we're trying to prove. We're trying to prove two lines parallel. What needs to be true for two lines to be parallel? We need alternate interior angles to be congruent. We did it. So if alternate interior angles are congruent, then lines are parallel. Phew. All right, thanks for giving me that extra 32 seconds. All right, everybody. So your assignment is in your packet. For you guys, it's going to be on a specific page. So you'll be working on the third worksheet, working with CPCTC.